Hello everyone. Today I want to be talking about multiplication with vectors. So first I have to introduce an idea that is not a vector, and instead is kind of the opposite, and it's called a scalar. A scalar is anything with just a magnitude. So an example of this would be like a number, and then varying physical quantities that don't have anything to do with direction. A good example of this would be something like an electric charge. So, now we kind of understand what a scalar is. It's pretty familiar probably because it's pretty much everything you've been dealing with up until you learned about vectors. So, now that we know what a scalar is, I can start talking about vector multiplication. Now, there are many different kinds of vector multiplication. The first one I'm going to talk about is where we're going to take a vector times a scalar. Okay? And what we're going to find is that we will get a vector result. But this vector will not be the same vector as before. It will have a different magnitude. Okay? So, let's go ahead and experiment with how to do this. And I'm going to use a very, very simple vector here. So we are going to take the number 3 times vector A. And I'm actually going to stop using a dot to represent multiplication. You'll see why later in the video. We're just going to write it as 3A. Okay? Well, I'm going to define A as the same thing I used in the last couple videos. A is going to be a vector that has 2 units over to the right and 2 units up. Okay? So it's going to be this times 3, and we're just going to scale the magnitude up by 3. So this vector will have 6 units to the right and 6 units up because we are just increasing its magnitude by a factor of 3. So here we can find we are going to have 1, 2, 3, 4, 5, 6. This will be 3a in the x. And go up by 6. 3, 4, 5, 6. Okay. And this will be 3 times a in the y. And then we can just connect the two. And this will be 3 times the vector a. All right. Now, I want to talk about vector times the vector. And there are 2 different ways to do this. First way I want to talk about is a way called the dot product. You'll see why in a second. So, a dot product is going to mean that we take a vector and we multiply it by a vector. Here's where I'm going to use the dot. That's why I didn't use it earlier. And we will get a scalar out of this. Okay? So now, what I'm going to do, sorry, I'm going to have to move move it up a little bit there. Okay, so now what I'm going to do is I'm going to take the magnitude of this. Remember, it's just a scalar, so it will only have a magnitude. And I'm going to give you the formula for it as A times B, magnitude of A times the magnitude of B, times the cosine of the angle between them, theta. Okay? So if we say this is A and this is B, the angle between them right here, that's going to be theta. Okay? And then we can calculate the magnitude using this. Now this is a simplification of what a dot product really is. We are basically multiplying the vectors based on how similar they are. So we can say another formula for the dot product is the x direction of A times the x direction of B plus the y direction of A times the y direction of B plus the z direction of A times the z direction of B. Okay? So this is another way to write the dot product. If you use the law of cosines, we will find that these two statements are equivalent, and I challenge you to do that on your own. Okay? I want to talk about one more type. And now this is actually the most complicated. Save the best for last. This is the cross product. Again, you'll understand the cross in a second. But if we take a vector and we multiply it by a vector we say crossing it with the vector, a little cross there, we will get a vector out. We'll get a vector result. Okay, so now what we can say right here is that the magnitude of this vector resultant, I'm going to call this C. It's going to be equal to the two vectors that we crossed with one another. So this is the vector A times the magnitude of the vector B times the sine of the angle between them, which we call theta. Okay? But here's the rule about the direction of C. C is always perpendicular to both A and B. It's always. And this requires a third dimension to be true. So, what we can do here is we can do something called the right-hand rule, okay? Which says that if I take two vectors, we'll say this is A and this is B, then A cross B should be in the perpendicular direction according to the right-hand rule. So if you have two vectors, A and B, there are two vectors that could be perpendicular to them. One would stick out of the page and the other would go into the page. How do we know which one is the direction of A cross B? Well, you have to use something called the right-hand rule. So take your right hand, here's my right hand, and I put it on vector A. And then I bring my hand over to vector B. I project A on B. Well, I'll move over here. See, my thumb is sticking up. So this will be pointed out of the page. Okay? So the direction of A cross B will be out of the page. But now if we take B cross A, take my right hand, I have to flip it over like this in order to come here to B. Or A, sorry, in order to project B on A. And like this, my thumb is pointed into the page. Try it yourself if you're a little bit confused. And therefore, B cross A would be into the page. So, what we can say is that because B cross A is in the opposite direction of A cross B, we actually have another formula for this. We can say that A crossed with B is equal to the negative of B crossed with A. And remember that the negative here will just make the vector flip and point in the other way. Okay? Now, this is probably going to be about as complicated as you can get with vectors. The cross product's a little bit hard to understand, so I recommend you do practice whatever your teacher has for you to really understand this. Okay? That being said, we also won't need it for a while. Alright? Well, I think that's about it for this video. I hope you have a good day, good night, good afternoon, depending on wherever you are, whenever you're watching this. Alright, everybody. Hope to see you in the next video.